This video is for example 11. It follows straight on from example 10. In example 10, we learnt the moles of gases and how to calculate the molar volume of a gas and the number of moles of a gas. This time we're going to apply that to some problem-solving activities. So for question A, we've been told 150 grams of water is evaporated. What volume will the steam occupy at 25 degrees and 100 kilopascals? The catch here is that usually on the previous question, to calculate volume, we need to know number of moles. And they haven't told us the number of moles. So this is obviously a multi-step problem. And when you've got multi-step problems, a good strategy to use, particularly with the longer ones you do in the HSC course, is to figure out where you've got to be at the end and work your way backwards first. And the way to do that is to look at what data you've been given and then try and figure out a strategy to get to the answer you need. So the data for this question, the mass of water, we've been told we've got 150 grams of water. We can figure out the molar volume because we've told the temperature and the pressure. The question's asking us for, though, what's the volume? And unfortunately, considering the fact that our equation we need to use to find the volume is volume equals number of moles times molar volume, we can't quite get there yet, okay? Yes, we're trying to find the volume, and yes, we know the molar volume, but we don't know the number of moles. So what we do now is we think, well, we know the molar volume but not number of moles. We've got to find the number of moles first to calculate this question. And the clue for this question is they've given us the mass. Now, we're not using the mass in this equation, so this mass must be given to us for a reason. So we've got to ask ourselves, we need to know number of moles. We've been told the mass. Do we have an equation that involves the mass and the number of moles? And the answer to that is yes. We've got this equation we used before, number of moles equals mass over molar mass. And considering the fact that we've been given M, and we can easily calculate the molar mass of water, that means to solve this problem, first we've got to find the moles of water using mass over molar mass, and then we can calculate the volume of water. So first step, how many moles of water we got? Well, number of moles equals mass over molar mass, which is 150 grams, which we've been given, divided by the molar mass of water, which we can calculate, and that tells us we've got 8.33 moles of water. And now we can calculate the volume of water. Volume equals number of moles times molar volume, which is now this 8.33 value we just calculated, times by 24.79, tells us we've got 206.4 litres of water. But let's look at our data. 150 grams, two significant figures, and therefore our answer has to be to two significant figures. Let's look at example B. We've got 9 times 10 to the 3, or 9,000 litres of ammonia gas at 0 degrees was condensed into a container. What mass of ammonia will be in the container? So this time we're given a volume of gas. We've got to figure out what the mass of that gas is. So our data, we've been told the volume of ammonia. We can figure out the molar volume based on the fact that it's 0 degrees. We've been asked, what's the mass of ammonia though? Now, if we're trying to find the mass of a chemical, the normal equation we use is mass equals number of moles times molar mass. And in this question, we can easily find molar mass of ammonia, but we don't actually know the number of moles of ammonia yet. So we've got to find that first. So our first step is to find the number of moles in order to calculate the mass. And how are we going to calculate the number of moles? Well, the clue is the question is giving us the volume of gas. And do we have an equation that involves number of moles, the thing we're trying to find, and volume? Well, the answer is yes, we do. We have number of moles equals volume divided by molar volume, and we know the volume, we know the molar volume, therefore we can calculate the number of moles of ammonia, which is going to be 9,000 divided by 22.71 from our data up here. So we know we've got 396.3 moles of ammonia. Now we can calculate the mass. Number of moles times molar mass is going to be that 396.3 times the molar mass of ammonia, which is just 14.01 for the one nitrogen, and 3 times 1.008 for the 3 hydrogens. We do that in that calculation, we get 6,750 grams. But looking at our question, obviously we don't use these two numbers in our calculation, we can ignore them. This number here's only got one significant figure. There's only one number before the times 10 to the, and therefore we've got to convert that to one significant figure, which you'll find is 7,000 grams, or 7 times 10 to the 3 grams, or if you want to put it in kilograms, 7 kilograms to one significant figure.